Hello friends, so we have a question on application of derivatives. We are given that a particle is moving in a straight line such that its velocity at any time t is given by this particular function and the time period is varying from 0 to 3. Now we have to determine when the particle changes its direction of motion. So we have to understand that the particle changes its direction of motion when v is equals to 0. You can think of a ball. When we throw it up, at the top point it changes its direction of motion, and at this point it momentarily comes to rest. So its velocity becomes equals to 0. So t square plus 1 into cos t divided by 4 will be equals to 0 when the particle is changing its direction. Now t square plus 1 cannot be 0, so what is the solution will be cos t equals to 0. That means t can be either pi by 2 or 3 pi by 2 and so on. Now you have to understand that the value of t is varying from 0 to 3 only. So we can reject this solution because this will be 3 by 2 multiplied by the value of pi, which is anyway greater than 3. So this whole value will be more than 3. So the only solution is pi by 2, which will approximately be equals to 1.57 seconds. Now let us try to solve the second part. In the second part, we have to find the time when the particle's acceleration is minus 1.9 meter per second square. So we know the acceleration is defined as the first derivative of velocity. So we have to find dv by dt. The function of the velocity is given as t square plus 1 into cos t by 4. So the function for acceleration will be the first derivative, that is 2t into cos t by 4 minus, because derivative of cos t will be sine, so this is sin t divided by 4, and we can equate to minus 1.9 to find the value of t. Now you will use a calculator or the graphic display calculator for solving this function. For this I have already drawn this graph. The acceleration is 2t into cos t by 4 minus t square plus 1 into sin t by 4, and when we equate it to minus 1.9, we will basically try to solve this equation equals to 0. That is, equating this and then taking 1.9 to the left. What we are trying to solve is we will try to plot the graph and we will try to find the values of t for which this is equals to 0. So from this graph you can identify there are two values of time for which this will be 0, which is 2.263 seconds, and another will be t equals to 2.957 seconds. So these are the two values of time for which the acceleration will be equals to minus 1.9. Now let us try to solve the third part. In the third part, we have to find the particle's acceleration when its speed is at its greatest. So you can use this graph. You can plot the velocity as a function of t, which will be t square plus 1 into cos t divided by 4. On the x-axis we have plotted t in seconds, and on the y-axis we have the graph of velocity. So we have to identify the acceleration when its speed is maximum. So magnitude wise you can see the speed will be maximum at t equals to 3 at this point. So at t equals to 3 the speed is maximum. So you can identify the acceleration, and the acceleration can be identified as the first derivative of the function of velocity, which is 2t into cos t divided by 4 plus t plus 1 into minus sin t divided by 4. Now putting t equals to 3, you will get acceleration as minus 1.8377 or minus 1.84 meter per second square. Negative here reflects it's in the opposite direction. So this is your solution, and for more such questions and their detailed explanations, do visit our website and register for